Hello and welcome to G Fun Facts Online, the show that dives deep into the science that's shaping our future. Today, we're talking about something straight out of a science fiction novel. Imagine an invisibility cloak, lenses that can see things smaller than a wavelength of light, or buildings that can deflect the energy of an earthquake. Sounds impossible, right? Well, what if I told you these things are becoming possible, not through some magical discovery, but through an incredible field of engineering? Today we are entering the world of metamaterials. So what exactly is a metamaterial? The meta prefix comes from Greek, meaning beyond. And these materials truly go beyond what we find in nature. They aren't new elements dug from the ground. Instead, they are artificial materials, engineered to have properties that defy our expectations. The secret isn't in their chemical composition, but in their structure. Think of it like building with Lego bricks. The properties of your final creation, its shape, its strength, are determined by how you arrange the individual bricks, not just the type of plastic they're made of. Metamaterial engineers do something similar, but on a microscopic scale. They create tiny, repeating structural units called meta-atoms. These aren't real atoms, but intricately designed patterns made from ordinary materials, like plastics and metals. By arranging these meta-atoms in just the right way, they can manipulate waves, like light and sound, in ways that are simply impossible for natural materials. This leads to some truly mind-bending abilities. Let's talk about one of the most famous, negative refraction. Normally, when light passes from air into water, it bends in a predictable direction. We've all seen this with a straw in a glass of water. But metamaterials can be designed to have a negative refractive index, meaning they bend light in the completely opposite direction. Why is this a big deal? It allows for the creation of superlenses that can break a fundamental rule of optics, called the diffraction limit. This means we could create microscopes capable of imaging things far smaller than ever before, like individual proteins in action. And yes, let's talk about the holy grail of sci-fi tech, invisibility cloaks. The concept is no longer just for wizards and starships. By designing a metamaterial that can precisely guide light waves around an object, it could render that object completely invisible to an observer. Now, we're not quite at a full-on Harry Potter cloak just yet. Most successful demonstrations have been with microwaves, not visible light, and they only work over a narrow range of frequencies. But the proof of concept is there. The impossible is becoming possible. And this technology isn't just about light. Engineers are creating acoustic metamaterials to control sound. Imagine ultra-thin walls that are completely soundproof, or concert halls with perfect acoustics no matter where you sit. There are also mechanical metamaterials with bizarre properties. For instance, most materials get thinner when you stretch them. But auxetic metamaterials actually get fatter. This could be used to create incredible shock absorbers, or biomedical implants that perfectly mimic the properties of human bone. You might be wondering, how do you even begin to design something so complex? The number of possible arrangements for these meta-atoms is astronomical. This is where artificial intelligence comes in. AI models can sift through millions of designs in the blink of an eye, discovering new structures with the exact properties scientists are looking for. And to build these intricate, microscopic designs, we're using advanced manufacturing like high-precision 3D printing. The potential applications are staggering, and they touch almost every part of our lives. In telecommunications, metamaterials are leading to smaller, more powerful antennas for our phones and for the next generation of wireless communication. In medicine, they promise higher resolution MRI scans, better biosensors, and custom implants that your body won't reject. The aerospace and defense industries are heavily invested, looking at everything from advanced stealth technology to better radar systems. They could even make solar panels more efficient and create flexible body armor that hardens on impact. We are at the very beginning of a materials revolution. The journey into this metaverse of materials has just started. Researchers are now working on tunable metamaterials that can change their properties on demand, essentially creating programmable matter. As we continue to master the art of designing matter from the ground up, we are fundamentally rewriting the rules of how our world works. The line between science and science fiction is blurring, and the future built with metamaterials will be unlike anything we've ever seen before. Thanks for listening to G Fun Facts Online. Join us next time as we explore another corner of our amazing universe.